Hi, you're welcome to Comparing Africa's Regional Climate Data, a course project by REN R. In some parts of Africa, the climate has warmed by 2 degrees Celsius, higher than the averages of 1981 to 2010. The current changes have tremendously impacted the continent with increased occurrence of climate hazards and extreme weather events such as cyclones, droughts, and erratic floods, among others. The 2022 report by IPCC reports that the continent will most certainly face more hazards related to heat and precipitation, with an increased impact on food systems, ecosystems, freshwater, and livelihoods, among others. Evidently, the impacts vary across the African plain, with more areas having higher magnitude and rates of change, for example, the rapid expansion of the Sahara, while some areas like Mauritania maintain a cooler temperature. Whereas the rapid climate change is a global concern due to its impacts, the African continent is severely underprepared and adapted to these impacts, and yet research and climate data are still wide gaps, partially due to the sparse and intermediate weather station data and funding. This project aims to contribute to documentation of trends of climate data in Africa, with a focus on mean annual temperature and total annual precipitation. This research will serve as a basis for more localized research so as to inform tailored climate-related policy, and also a basis for wider research to develop free-scale climate data such as Climate AB and Climate EU. This research categorized Africa according to 7 climatic zones, that is the bushveld, desert, equatorial, Mediterranean, savanna, steppe, and the subtropical. The data used was meteorological station data obtained from the stations as shown in the map. The red dots represent the temperature stations and the blue dots represent the precipitation stations. This data was imported into R and checked for reliability. A visual analysis was done to show the recordings for each station. There was visibly fewer recordings for the period of 1900 to 1950 than the latter years. This was hence filtered out for the statistical analysis to be done. The 2 box plots show mean annual temperature for the 7 climatic zones. The figure on the left represents data where outliers were present, and the figure on the right represents data where outliers were removed. The mean annual temperature was analyzed using EM means as shown in the graph. The analysis showed that the savanna, the subtropical, desert, and equatorial generally had a higher mean annual temperature, ranging between 21 degrees Celsius and 26 degrees Celsius, higher than the steppe, the Mediterranean, and the bushveld. The differences could be explained by a number of factors, including the distance from the equator and the tropics of Cancer and Capricorn, and the cooler temperatures of the could be influenced by the sea and the occurrence of intertropical convergence zones that hail cooling currents over those regions. The bubble plot at the bottom right indicates the decadal changes of temperature over the years, where the blue represents a decrease in temperature over the decades and the yellow represents the maximum increase. It shows that the regions closer to the midriff or equator experience less change in the trend, whereas the regions at the extreme of the continent showed increasing temperatures over the years. The total annual precipitation varied for the different climatic zones, with the equatorial having the highest, ranging from 1,400 to 1,900 millimeters, a feature attributed to its vast rainforest of the Congo and West Africa. The subtropical region also experienced high precipitation attributed to the vegetation such as the Miembo woodlands and the montane areas in that region. the steppe registered the lowest precipitation, presumably due to the maritime air mass that stays offshore, thus hindering grain formation in the region. The situation is not shared by the Mediterranean, as they receive winter cyclones that induce precipitation in the regions. In conclusion, the findings of this research affirmed findings by other researchers regarding the increasing temperature. Secondly, some areas were more affected than others, implying that they had higher risks to the impacts of climate change. This research will also form a basis to the development of software to provide free-scale climate data for Africa. Thank you for listening. These were my references.